This is the bicycle top assembly video, part 2. In part 1, we partially assembled together the bicycle welded frame and the larger components. We started with the bike geometry file to create some convenient mates. Then we inserted the welded frame, the fork, the rear wheel, front wheel, crank, and bottle cage. For this video, we will concentrate on all of the parts associated with the seat and all the parts associated with the handlebars and the stem. First thing to do is start with the seat post. So insert component, and then browsing to the appropriate directory. And this is one of the parts that has been supplied to you in the components kit. So we will look for the seat post, open. Just drag this into place, and this is in the wrong orientation. This portion should be facing backwards, so I will just rotate that like so. My first mate will simply be to make a concentric mate between this surface and the inner surface of the seat tube. So mate, I've already selected this surface and this surface. Defaults to concentric. I've got that in place. The second thing I want to do is prevent this from swinging back and forth. So I will mate the front plane of the seat post with the front plane of the assembly. So now this can still move up and down, but it can't swing side to side. The next thing to bring in is the seat post clamp, which goes down here and tightens around the seat tube to prevent the seat post from slipping. So insert component, existing part, and again, this is one of the ones supplied to you. So we go down to seat post clamp, open, bring this into place, and again we will make a concentric between this surface and this inner surface here. And we will make a distance mate from the top surface of the clamp to the top surface of the seat tube. So selecting this surface and this surface, it defaults to coincident. We will change that to a distance mate. And I will make this about 3 millimeters, and I will flip the dimensions so that this is coming down below the surface of the seat tube. I can still rotate this back and forth, so the last mate I want to make is between the front plane of the clamp and the front plane of the assembly. So going down to the clamp, opening it up in the feature tree, I select the front plane of the clamp, scroll back up, the front plane of the assembly, that defaults to coincident, and I finish that part. Now we can add the seat clamp at the top of the seat post. So insert components, browse, and go to the seat clamp. Open, bring this into place, and we want this curved surface here to sit in this curved surface here. So mate this surface here, this surface here. That will default to concentric, so that should work. And once again, we need this to be on center with the bike, so we can choose the front plane of this clamp and the front plane of the assembly again, and that brings it on center. I'm going to leave this so that I can still pull this stuff up and down and also rotate this clamp back and forth. The next step is a special nut that goes into this curved surface of the seat clamp. So insert components, browse. Again, this is a part supplied to you. We want the nut seat clamp, open, drag that into place, and we will make a mate between this curving surface here and the curving surface of the underside of the nut. And again, that should just default to concentric. And again, we see that this is way off axis, so let's close this here, open up the nut feature tree, select the front plane of the nut, the front plane of the assembly, and that pulls that into alignment. Now what's going to happen later on is a screw is going to come up through the bottom of the seat post and thread into this nut. That means that this hole in the bottom of the seat post has to be in alignment with that hole in the nut, or the screw won't be able to thread in. So we will do another mate here, and we will select this hole in the seat post and this hole in the nut. This will default to concentric, which will bring those on a common axis and finish that mate. These are still not completely defined in position. If we look here, we see that there is still a minus sign next to the seat clamp and the nut, and that's okay. In a few more mates, everything will be locked down into place. The next obvious part now is the seat itself, and you'll recall the seat has rails on the bottom, and those rails are clamped in these circular grooves by the two halves of the seat clamp. These grooves are 43 millimeters apart, and that is the distance that the rails on your seat need to be, otherwise you're going to have trouble mating this. The seat is one of the parts that you created custom as a project. So insert components, and browsing, this time going to my custom parts that I designed, and I'm going to select my saddle, open, and drag this into place. And the first thing I want to do is make a concentric mate between the rail and this clamp. So mate, select this rail, and either of these two surfaces, they form one contiguous circle, so I'll just click on this surface. That gives me a concentric. And I finish that mate. And now I can click on the other rail on the opposite side and this groove here, and that should give me a mate also. If these two dimensions are not perfectly matching each other, you won't be able to do the second mate. Let me close the Mates Property Manager for a moment and just demonstrate that I can still move this seat back and forth and up and down. And if I grab things properly, you can see I can even tilt it up and down like this. So the next few mates are going to be the final constraints that get the seat in the right position. Now's the time to unhide our sketches again and use the geometry sketch to get these final constraining mates on the seat, which will cause all the other connected parts to be constrained as well. So unhiding my features, you recall that in your geometry file you set the seat at whatever was the optimum height for your leg length. So the first thing I will do is just mate the top of the seat with the top of the sketch in the geometry file. And what I'm going to do is just mate this center line on the seat with this point in my geometry sketch, and that will pull the seat down to the proper height. So going to mate, just selecting this entire edge along the mirror plane of the seat, and then selecting this point in my geometry sketch. That pulls the seat down to the proper location. Now I want to bring the seat forward, and once again I will take advantage of my geometry sketch. I will align the plane that is at the nose of the seat with this point in the geometry. So clicking open my feature tree here so I can see the right plane for my seat, and holding my control key and selecting this endpoint here, select mate, and that will mate these two. But you see, of course, the seat is tilted at an odd angle, so now I can rotate this into place. What I probably want to do is just make the top plane of the seat parallel with the top plane of the assembly. Or I could add an angle mate if I wanted to adjust the angle of the seat a little bit. But I will just make the top plane of the seat parallel to the top plane of the assembly. So selecting the top plane of the seat, scrolling to the top, and I'm holding my control key top plane of the assembly, mate. I can't do a coincident, but I can do a parallel. We see that brings everything in alignment. Finish the mate, and that gets all of the features related to the seat fully locked down, and we see no minus signs next to any of those. Now we will finish this video by mating the parts related to the handlebars. Probably the best place to start is the stem, which goes up here. So insert components, browse, and this is one of the parts you made as a tutorial. Here's my stem, open, and I need the stem to be oriented with the steering tube. I can make a mate between the stem and the steering tube, or the stem and this line in the geometry file. Both will give me the same result. So mate, selecting this inside cylindrical surface and the outside cylinder of the steering tube. That aligns the stem that way. And you'll recall that we want these parts, such as the handlebar and the stem and the fork, to all turn together. So as we add all of these parts up here, we will constantly use the front plane of the fork to set the orientation for those parts as the fork turns. So opening my feature tree here, going to the stem, and selecting the front plane of the stem, collapsing that, and then going to the feature tree for the fork and selecting the front plane for the fork. That defaults to coincident, and we hit the green check mark. The last thing we have is a line in our geometry sketch that represents where the top of the stem is supposed to go. I will just click on that line and the top surface of the stem, and that brings the stem down to where it belongs. Now if I zoom out and turn the stem, we see that the wheel turns with it. Now I can pretty much hide the geometry file and just make direct mates between parts. For the next step, I can add either the handlebars or the stem cap. Stem cap is easy, so I'll do that one. Insert components, browse. And again, this is a part supplied to you. Open, bring this in place. This is an easy one. You just make a mate between the underside of the cap, this surface here, and the top side of the stem. That aligns those with a coincident. And then I will just select the cylindrical surface on the inside of the stem, and I can pick either of these two cylindrical surfaces to get a concentric. And I don't really care how this is rotated since it's circular, and I will just finish that mate. Now I can bring in the handlebar. This is a part you did as a tutorial. So insert component, then browsing to my tutorial parts, my handlebar, open. You see the handlebar comes in a slightly different orientation from the other parts because we built it using a different coordinate system. So using rotate component, I'll get this approximately in the proper location. And I will make a concentric between the handlebar and the stem clamp. So mate here and here, that defaults to concentric. And we'll just pause for a moment and see that this handlebar is not centered yet with the stem. So again, we want to use the front plane of the fork to align to the front plane of the handlebar so it's centered up. So just open up the handlebar feature tree. I'm holding down my control, selecting, in this case, not actually the front plane, but the right plane because we built the handlebar in a different orientation. It's the plane going through the center of the handlebar in this case. Scrolling up to the top, opening up the fork again, selecting the front plane of the fork, mating those together. You see that drags the handlebar in alignment. And pausing again for a moment, I see that I can only swivel the handlebar back and forth. and just testing to make sure I haven't done anything wrong, I can still pivot the fork back and forth so I haven't made any mates that prevent that from happening. So I want to add one last mate that will control this position of the handlebar. What I can do is use the vertical plane of the handlebar and make that parallel to the vertical plane of the fork. In this case, the vertical plane of the handlebar is the front plane, and we know that the vertical plane of the fork is going to be the right plane. So I've already got my front plane selected for the handlebar. Scrolling up here to the top and going to my fork and opening that up, I will hold my control and click on the right plane of the fork, which is back here. Selecting mate, and of course we cannot make a coincident, but we can make a parallel relation, and we see that that pulls the handlebar up vertical. Now maybe you want it tilted back a little bit or angled forward a little bit. You can always change that to an angle mate instead of a parallel mate. So just finishing that, and we should still be able to move the fork back and forth, so that's good. The last two items are going to be the bearing cap, which goes here, and a spacer that bridges the gap between the bearing cap and the underside of the stem. So we will start with the bearing cap. Going into Insert Components, Browse, and this is one of the components that's been given to you, so we'll go to our kit and select the bearing cap, open, and I can make the bearing cap concentric with the steering tube. And I want the top of the head tube and the underside of the bearing cap to be mated. And now we see this gap between the bearing cap and the stem. Before we put the spacer in, what we want to do is measure this gap. So we'll go to Evaluate, Measure, and between this surface and this surface, we find a distance of 11.867 millimeters. Now spacers are typically sold in increments of 1 millimeter, so the closest thing to that 11.8 millimeters is going to be a 12 millimeter spacer. For you, you might end up with a different dimension. You could have a spacer as little as a few millimeters or as much as, say, 20 millimeters, although that's a bit extreme. Now the thing that's going to define the true top location of the stem is actually going to be the stack height of the bearing cap, the spacer, and the stem itself. But you'll recall that we made a relation between the top of the stem and this line in the geometry file. We can't put a 12 millimeter spacer in here and also have a coincident relation to this line. So we are going to actually undo this one relation now that we found out what this gap is. So collapsing my feature tree and reopening the stem, I will take a look at my mates, and I want to delete this mate that has the coincident between the top of the stem and this line in the geometry file. So just right-clicking on that, delete, and that allows me to move this up and down. So I will make a nice big space here to put the spacer in and then remate everything together. Before doing that, let's open up our spacer file. So File, Open, and this is one of the parts given to you in the components kit. Here's the spacer, and this spacer has a thickness dimension of 12 millimeters. You need to change that to whatever is the closest millimeter increment to the gap that you had when the top of the stem was mated to the geometry file. When you change that, you might want to rename or resave this file under a new name according to whatever the size of the spacer is. The 12 millimeters will work for me, as you saw when I made a measurement of a little more than 11.8 millimeters. So going back to my assembly, I will insert components, And here's my spacer in my box here because I just had that open. So I can just drag that out to here and add some mates. Concentric between the steering tube and this inside cylinder, and a coincident between the top of the bearing cap and the underside of the spacer, and a coincident from the underside of the stem to the top side of the spacer. And that pulls everything down together. And if we zoom in really close, we see now that the top of the stem is very slightly above the top of the line in the geometry file. So we have just one last part associated with the handlebars, and that of course is the grips that go on the end of the handlebars. You'll recall that this was a tutorial part and you made about 5 different versions of the grip. Pick the one that you like the best. So insert components, browsing to my set of tutorial parts, and I'm going to select grip number 5 that has the interleaved dimples and drag that into place here. And now make a mate between the inside of the handlebar grip and the outside of the handlebar itself. You see this is flipped around the wrong way, so I will just toggle the mate alignment to flip that around. Click that, and I need to make a mate between the end of the handlebar and the bottom of the grip. So let me just slide this off for a moment. And it's a little bit hard to see the bottom of this, so now we can get in here, click on this surface here, and rotating back, clicking on this surface here. That brings that into alignment with the end of the handlebar. The other way to select the bottom of the handlebar grip on the inside is to right-click on the outside surface and use the Select Other option, and then click on the face that you want to select. So for this video, we won't be putting in the other grip. In the following video, when we put in all the hardware, we are going to be making some patterns, and we will also be using some mirror features to put the grip over onto this side of the bicycle. So that completes this video, and we're almost completed with the bike. We just need to put on the chain and all the nuts and screws that fasten the bike together.